Okay, let's start making a tool. Have a nice clean workshop with an old bedside cabinet. Get your piece of 19mm by 2mm tubing and put it in a vise. I've got a pipe vise here which we'll use later. It's very hard to get hold of nowadays. And now we'll mark it to length. Here's how you mark steel. That's how I do it. Out there. Okay. Nice scribing point. There we go. Okay, I'll just use pipe cutter. This is really for soft metals like copper and aluminium, but it works quite well on mild steel. I don't know how long the cutter will last, but I've been using one for years. You'll get the end of the tube perfectly square, which is an advantage in our application. Voila. Okay, rat tail file. Take out the burr. Now where this is electro resistance welded, you can see there's a seam down there where the metals rolled around and then it's welded. Where it's joined, inside there's a minute seam. Okay, this handy device here is known as a pipe vise. If you see them around, buy one. Not a lot of new ones around that I could find. This is a fairly old machine. Had it for a while. As you do it up, the chain grabs it, and the chain is specially shaped so it's got a radius on it, so you don't get too much distortion in the tube. You know, you don't want to make the tube out of round. You want this nice and round. This is called a reamer. Okay, it's just a cutting edge with straight flutes on it. As you can see, I've been using it quite well. This is a hand reamer. You can get them to fit in machine tools. This one's got the head of it machined square. Now the inside diameter of the tube is exactly 15mm, not 19 as I said before. It's exactly 15mm, or close to it. But I want it exactly, and this is manufactured in a drawing process, so it's not going to be exactly 15mm. So there we go. That's the weld coming out. Okay, one in. Do the other. You can do this in a vise, of course. Some vices are like a pipe drawing. Use that if you've got it. I like this. Okay, highly technical way of making a handle. What are we going to use? My daggy old hammer. You know, I've had this for 40 years. Yeah, I'm that bloody old. Mark off a bit on the end. It's that's 255mm long. That's what I'm making. Doesn't matter. It's just a locking camera. You know, make them longer if you like. And I've come in 35mm to make my handle. 35. There. Why important at all. And get your iron. Type 90. Voila. One locking tang. Okay, well here we are. We've just filed off or ground off a millimetre off the edge. We made that 15 millimetres wide. Now, you understand this is not exact science. It's only going to be thick enough there. Now you notice I've actually taken the mill finish off with a file, and actually I did this with a sanding belt. It's going to end up like that anyway from being pushed in and out all the time. And it depends how often it gets used, obviously. So it just helps the fit, but also in the end when you're finishing it makes things fit together better, you know, and they slide together better. Now the idea is that the tang ends up flush with the end when it's pushed in. Okay, so nice and smooth, no catching, you don't want it to catch. Okay, now take that edge off there because that affects the thickness along the edge. Okay, very good. Okay, once again, marking. Tang has got to be 200 millimeters. Same method, I always mark out the same way in steel. Okay, this is an ordinary pair of bolt cutters. They're pretty big ones, they're 4 feet long. You can use smaller ones, you can use a guillotine, or you can cut these with a hacksaw. Doesn't really matter. I'm a bit of a lazy man, so I'll cut them with the machine. Okay, moving into phase 2. Now we've got two pieces of 13mm by 5mm flat steel, which are now 200 millimeters long, 200 mils long, or thereabouts. And I just made sure they're the same length because it's neater that way. Okay. Now we've got to grind a chamfer off of each edge of these flats on the top. Now, just to tell you here, if that's 13 millimeters wide, then the chamfer on the corner isn't quite 45 degrees, it's 47 degrees down that way. That's to fit inside a piece of tube that's 15 millimeters inside diameter. Okay. What will happen is if you get as close as you can to this ideal dimension, then it will fit nice and neatly inside the tube. Here's a bit of tube, 175mm long. If you can work tidier in your workshop, then do. But you see, these two fellas fit in here, which is what you want, but the gap isn't big enough. That's all the problem is. You know, and you need at least 3 millimeters in the middle, otherwise the jaws can't come in far enough to engage in the sleeve. Okay, so before we start that, once again, marking out steel, you usually scribe a line on top of something blue, black, whatever your convention is where you are. The only purpose is to make it easier to see, and also we'd like this to be reasonably close to the proper dimension. This is just a permanent texture colour model. Okay, now according to our bit of paper, the distance from that edge to the top of to the inside of the chamfer is 2.236. Now there's not a hope in hell we're going to make it 2.236, but we'll probably get 2.3 in a bit. So we've got this is a vernier scale with a scribing point in this tool. Very handy. You could use a metal ruler or whatever, but try and make it as accurate as possible. Now we made that nice and black. Just run down the edge here. So you can get a little roller. These are high precision, by the way. Very handy. Just steady it a little. See a nice line. On the other side. You can use files and vices and hand tools and rusty old nails. It doesn't matter as long as you end up with what you designed. You know what you need in the end. How you get there is up to you. I'm showing you the way I do it. You might do it a different way. I'm going to use a grinding wheel. I think a lot of people have got grinding wheels, bench grinders, so I'll show you that. But you may have just files, like ordinary files. They work just as well. People have been doing it that way for thousands of years. But have good measuring instruments. If you're going to spend money on anything, don't buy a fancy grinder or anything like that. Buy a good measuring instrument like this vernier scriber. My bit of paper says the other way. Down, it's 2.408, so 2.4 millimeters down the side. So is this useless? Am I just showing you as a suggestion? See, that's not exactly super duper flat. It's not machined or ground or anything like that. So this scriber's giving you the distance, and when you got it all together, it'll all work out. In theory. More talking, less scribing. There we go. So there's where it grind across. Now it doesn't look like much, but it's the difference between fitting nicely inside that tube and not fitting nicely. I worked out the dimensions so that if that tube is 15mm inside diameter and these bits are 13mm wide flat and have this much taken off the corner, then they'll fit in there with exactly a 3mm gap in the middle. Won't that be handy? Okay, now just pretend this is a beautiful, pristine, clean bench. This is my bottom shed, and you get what you get. I could show you in a big fancy workshop how to do this, but what good would that be to 99.9% of the people watching this? Most of you got a shed in your backyard about the size of a bird bath, and you got hand tools. So we'll do it that way. Now I made a jig. I got this, right? Buy one of these. They're pretty economical. We get them all over Europe. On eBay if you want them. But this flat sanding belt, very, very handy. Okay. Now I made this jig up. Took a little time to do it. But basically what it is that angle there, that side angle there, that is 47 degrees. And that angle there is 43 degrees, so that is perfectly 90. Well, I made it so it fits nicely over this belt cylinder here. Okay. Let's check the fit here. Now here's our piece of steel that we marked. Now we know that when we put that in there, that is the correct angle that we showed on that drawing. And I'll just draw that off across there by hand until we get to the line. And that's the science of it, man. That's all we do. So, let's start. Now that's still a bit tight. See, it goes in. So I'd guess if we were able to measure that nest of steel, that would be very close to 15mm in tolerance, but it's too close. It's an interference fit rather than a clearance fit. Okay, a little bit more, and let's assemble these three pieces, the inner tang and the two outer tangs. Well, that's the locking tang, I suppose you call it. Now, so here we go, yeah? Voila. Because we've done this by hand and not on a machine, sometimes it will fit better if you turn them around, you know, because we're trying to do something that a machine would normally do, but we're doing it by hand. But bear in mind, they built pyramids 4000 BC or whatever, so does it fit together? Well, we've mucked around and filed and ground and so on. So what happened? Now observe, we've got quite a nice neat fit. Now these jaws will be sticking out 6mm at the tip that goes into the engine that way, and that gives you enough sitting out here to grab hold of with a spanner or whatever. You know. Now this is the main part of the work done. The only real hard work now is cutting the thread on the outside of that tube. But that's basically what the tool is, you know. So we pull that fella, that's it. Okay. So the smoother you get this action, the better it is, you know. Drop a bit of oil down there, just check your fits. Fine. It's actually most important, it doesn't matter if it's too loose here in the body, that's basically holding the thing so it transfers force properly and it's get a lot of stress on it. But here at the tip, we're going to be drilling in some holes, which we'll see in a minute, and these things can twist under that enormous force if it ever gets that hard. So it's here at the tip where the two hardened steel locking dogs come out that you want to have a fairly nice fit here. I prefer doing it this way because it provides basically when that's together, that's a solid 19mm piece of steel billet, you know? And even though this is not high tensile, it's still 300 megapascal yield steel, so it's a substantial tool. It's got a lot of strength in the body. Is that important? Well, when you start pulling the bloody sleeves out, then you'll find out.